This lecture is over Chapter 2 of Concepts of Database Management by Pratt-Adamski, accompanying class CIS 307. Relational databases are discussed in your chapter on pages 31 to 33. A relational database is defined as a collection of tables known as relations. And a relation is defined as a two-dimensional table in which, number one, the entries in the table are single valued. That is, each location in the table contains only one value. Each column has a distinct name, technically called the attribute name or the field name for that column. Thirdly, all values in the column are values of the same attribute. That is, all entries must match the column name. Fourth, keep in mind that the order of columns is immaterial. It's extremely important to understand that each row is distinct. And finally, the order of rows is immaterial. Your text has some great examples of some two-dimensional tables pictured on page 32 using the Premier Products database. So you have your rep, customer, orders, order line, and part tables. What's important to understand is that in order to create that relationship, you have to have a primary key. And your text defines a primary key as a field or a combination of fields that uniquely identifies each record in a table or each row in a table. Remember that to create that relationship, though, you also have to have a foreign key. A foreign key is a field that is not necessarily the primary key of that table, but it is the primary key of another table, or at least part of the primary key of another table. Your author never uses the term foreign key, only refers to primary key, but it's an important concept to understand what the foreign key is as well. The relationship is created when you create a connection between the primary key of the primary table and the foreign key of the secondary table. Remember when we looked at this picture in Chapter 1? This is the rep table on the left and the customer table on the right. The primary key of the rep table is rep number, and the primary key of the customer table is customer number. The rep number uniquely identifies each sales representative. The customer number uniquely identifies each customer. However, the customer table contains a field called rep number. So when it says that customer 1 is John Smith, etc., and then it says that his rep number is 43, that means that sales rep number 43 represents that customer. Notice the one-to-many relationship is created when you take the rep number from the primary table and drag it to the rep number of the customer table. In customer, rep number is what is known as a foreign key. And in rep number is the primary key. So again, a relationship is created when you draw a line or you somehow connect. In Access, you draw a line. In other programs, you may programmatically connect the two tables, joining them together between the primary key of one table and the foreign key of another table. Not to confuse you even more, but remember, the two fields do not have to have the same name. They have to represent the same data. They commonly do have the same name. I'll tell you from experience, it saves you a lot of headaches if you're designing it yourself if they have the same name. But keep in mind, you may encounter times where the primary key and the foreign key that you're creating the relationship on don't have the same name. The bulk of the chapter talks about query by example and uses Access in order to demonstrate these query by example examples. QBE is an approach to writing queries where you actually show it. You don't need to have any programming language, programming background, or any SQL. So we're going to go through these examples in Access using the Premier Products database, and you can follow along in your text and watch here as we create each query. If you've used Access before, then you probably should be able to create these queries yourselves, but since Access is not a prerequisite for this course in any way, shape, or form, I wanted to spend the time to actually show you how to create each one of these in case you've never done it before. So I've opened my Premier Products database, and remember, if you have that security message, you do have to enable content. And I've gone to the Create ribbon, and I'm going to go ahead and just open up my query design. This gives me a blank query window and the Show Table dialog box on top of that window. One way to get a table into my query is to simply double click the table name, and you'll see the table appear up here in the top half of the query grid. For this first example, that's the only table I want, so I can go ahead and close the Show Table dialog box. For this example, I want to list the number, name, balance, and credit limit of all customers in the database. So I want to list the customer number, name, balance, I can make this a little taller, balance, and credit limit of all customers. Notice that I simply double-clicked each of those fields to make it pop into the bottom half of my query grid. Notice that the first row in the query grid tells me the field name. The second row tells me the table that the field came from. This label table is a little misleading. Sometimes you will want to query a query, but it really should say record source. And then notice the fourth row says show. As I double-clicked and added each field to this query, this checkbox to show is automatically checked. And more often than not, you're going to want to have that checkbox remain checked. I always mention it early because a new student often will uncheck it and then be surprised when they go to look at the results of their query that that particular column does not appear. They'll come back in and look and go, well, the balance is there, and what they've done is just inadvertently unchecked that box. So in other words, that column was not showing even though it was selected in the query. So here's my query. Again, my table's at the top, my 4 fields are at the bottom. The first icon on the left switches me between the data view and the design view. So when I look at these results, I'm seeing all my customers, their customer number, customer name, balance, and credit limit. Now the difference between this and just looking at the customer table is the customer table has other columns in it that I don't need right now. That's one reason to create a query, is to not see all of the columns in any particular table. I'm going to go ahead and save this query, and I'm going to name it QRY Example 1. And I'm going to go ahead and close it. The second example, pages 36 to 37, they want us to list all fields and all rows in the orders table. So I'm going to start off and create a query using that query design from my Create ribbon. And this time I'm going to double click Orders so that it's the Orders table that appears up here, and I'm going to close. Now, there's a couple of different ways to do this. What the author is showing you on page 37 is that while you have the 3 field names here, that you also have a little asterisk or star up here at the top. And that if you double click the star, notice it appears only in the first column here. But when I view, first icon on the left, it actually means all. So that little star takes up only one column in my query grid, but it shows me all the columns, whether there's 3 or 30 in the underlying table. And to many users, that at first seems like a great advantage. And if truly all you want is all the columns in that particular table, it's very helpful. But sometimes, as you'll learn, you'll want to apply criteria to one of those columns, or maybe specify a sort order off of one of those columns. Well, because you did this with the star, you can't turn around and specify a sort order on one of these 3 fields or a criteria on one of these 3 fields. So I'm going to go ahead and get rid of that by simply deleting it out of there. Instead, look at this trick. If I double click the title bar of this table, It selects all the fields in that table, whether there's 3 or 30. Then I can point at any one of them, click and hold, and simply drag it down into the first column. This also added all the fields from the table into the query grid below. The advantage, however, is that each field is in its own column, allowing me to specify a sort order or criteria on one of these fields. The end result when I look at my my data view is exactly the same. I see all the columns and all the records. So the author demonstrates on page 37 the star, and I've just demonstrated how to just do each field separately. So I'm done. I'm going to go ahead and close and save that query and name it QRY example 2. Our third example is in your text on pages 37 to 39. They want us to find the name of customer 148. So we need the customers table. So again, I'm going to bring open that query design. This time, just to show you a different way, let's say that you inadvertently closed this show table dialog box before you meant to. That might happen maybe if you had data from one table and then decided you wanted data from another table as well. Maybe you've already closed the dialog box, you now need to bring it back up. Maybe you closed it by accident. So when I'm up here in the top half of my query grid, if I simply right click, I can choose Show Table. And all that really does for me is bring the dialog box back up. That's going to work no matter what version of Access you have. In the more recent versions, when you're in the query grid, you're on this Query Tools Design ribbon, and there is an actual icon here that says Show Table. That's another way to bring the dialog box up. In the case of example 3, we want the customer table, so I'm going to go ahead and double click it and then close the dialog box. I'm going to go ahead and increase the size of that table since I have plenty of room to be able to see all of my fields. For this example, they wanted us to list both the customer name and the customer number. So I'm going to go ahead and double click customer name, and then I realize, oops, I meant to put the customer number first. If I double click customer number, it's going to automatically go into column 2. If instead I grab customer number and I drag it down into column 1, it will actually insert itself right before customer name. So if you want a particular field to come into your query grid in a particular column, simply drag it down and place it into that column. When you let go, everything will have shifted over to the right, making room for that new field. Okay, this time we have criteria. We don't want to see the customer number and name for all the customers. We want to see it only for customer number 148. So in the customer number column criteria row, I'm simply going to type 148. And now when I view, you'll notice I only see the customer name and number for customer 148. I'm going to go ahead and save this one and name it QRY. Wrong icon. Save this one and name it QRY example 3. I'm prefacing my queries with that QRY as part of my naming conventions. Remember, your author does not discuss naming conventions, but experience. I've been working in databases for many years, and experience tells you that whenever possible, you want to have some type of naming conventions, especially on the names of your tables and queries, possibly even into your forms. Okay. I see I saved the wrong one. Let me save that again. Query example 3. Yes, I want to override, and we're good. For our fourth example, which is on pages 39 to 40, they want us to list the description, the on-hand value, and the warehouse number for all parts that have more than 10 units on hand and that are located in warehouse 3. All of this data is in my part table. So I'm going to go ahead and begin by opening my query grid with the query design button. And again, to learn something new, let's pretend that this Show table dialog box, once again, for whatever reason, is not there. If you're in Access 2007 or later, when you're in the query grid, you still see your database object window over here on the left. So I can just grab a table or query from the left and pull it right out into the window. I really don't need to have that show table dialog box at all. It just is, again, another way to get the data set, the table or query, into the new table window. I want the description, the on hand, and the warehouse fields. My criteria this time, I'm using some operators. I want greater than 10. So for criteria in the on hand column, I'm going to use greater than 10. And it said, and it had to be in warehouse 3. So I'm going to go ahead and put a 3 over here for warehouse. Now when I take a look, I'm going to have 4 records. These 4 records all have an on-hand quantity of greater than 10 and are all in warehouse 3. That example also introduced you to using the greater than sign, and there are a number of basic comparison operators that you're going to see Access and numerous other programs use. Your author does not include a list of them, and by no means is this an all-inclusive list. These are just some of them that I'm commonly going to see on a day-to-day basis. The greater than sign simply means greater than, but sometimes you want greater than or equal. In that case, you put a greater than and an equal sign right next to each other. Less than, again, less than, equal, right next to each other. No space between those two keys as you type them in order to mean less than or equal. Not equal is the less than and greater than signs with the open ends facing each other. And then, of course, you think, well, what about equal? You can use the comparison operator of equal. However, there really is no need to in Access. In Access, the lack of an operator means equal. So just not having any of the other ones means equal. There's a few other a little more complex ones. Still, I see these and use these on a daily or at least every other day in my work. Between. Between is an example of that would be I would put something in the criteria like between 1 and 10. That's the same as saying it's greater than or equal to 1 and it's less than or equal to 10. Remember, between is inclusive. So if I say between 1 and 100, the numbers 1 and the number 100 are included. Sometimes you'll have a string of items and you'll use the keyword in. For example, in, and then after a space and a parentheses, you'll list. And usually you'll see through anywhere from 2 to 5 maybe items: Iowa, Illinois, Wisconsin. So that means that I want one of these 3 must be the state. Another way to do this would have been to just put IA or IL or WI all in a string or as a key word. So it's the same as saying that it's equal to Iowa or it's equal to Illinois or it's equal to Wisconsin. Any one of the 3 would be acceptable. You just similarly see not in. And not in, for example, simply putting the word not here in front of that string is saying it's not in Iowa, Illinois, Wisconsin. It's the same as saying not equal Iowa and not equal Illinois and not equal Wisconsin. I missed my and here, but meaning it's not equal to any of those. Another keyword you might see sometimes is null. That means that it contains no value. And the opposite of that would be is not null, which means it contains any value. So these are criteria, comparison operators that you're going to see in your criteria in an Access queries on a very regular basis. So as we go back to our Access database, this one, again, example 4 had our on-hand greater than 10 and our warehouse as 3. Now do you notice that after I went and looked at the data, when I came back, it put quotation marks around my warehouse number? So I'm going to go take a look at the part table itself. Right click on part and choose design. Notice that warehouse is not a number field type. It is a text field type. Anytime a text field type is used in Access, you'll need to have quotation marks around it. The good news is that most of the time Access will put the quotes in for you. So I never typed those quotes. And of course in the on hand it did not put any quotes, and that's because in the part table on hand is a number data type. So I don't need the quotation marks. I'm going to go ahead and save this one and name it QRY example 4. So I can refer back to it if I need to. Example 5 is on pages 40 and 41. They want us to list the description, the on-hand value, and the warehouse number for all parts that have more than 10 units on hand or are located in warehouse 3. It seems very similar to example 4, doesn't it? So I'm going to go ahead and start off by looking at the design of example 4. The difference here is in example 4, it had to have an on-hand quantity greater than 10 and be in warehouse 3. Now we want it to be an or. I'm going to take that 3 and cut it out of there, and I'm going to move it down one row. Notice now the greater than 10 and the 3 are on separate rows. Notice how this column over here on the left is labeled or. This row, is labeled or. And there are numerous other rows then that have no label at all. And if it's not enough, I can add more. Each of these rows is considered to be an or. If criteria from different fields is on the same row, it's an and. Both or all criteria must be true, must be met. If the criteria is on different rows, it's turned into an or. So when I look at this now, what I'm seeing is on-hand quantities greater than 10 until I get down to this last one, this dishwasher. But it's there simply because it's in warehouse 3. With an or, I'm saying the on-hand must be greater than 10 or the warehouse is equal to 3. Both criteria do not need to be met. Because I want to save this separately from my example 4, I'm going to go File, Save Object As, and I'm going to change that to say Query Example 5. And I can go ahead and close that. Example 6 is on pages 41 and 42. They want us to list the number, name, and balance for each customer whose balance is between $1,000 and $5,000. So all of that information is in the customer table. So I'm going to go ahead and create a new query. I have added that shortcut to my own quick access toolbar up here in Access. So you can do that if you want, or you can continue to go to the Create ribbon and choose Query Design. I'm going to add the customer table and close the dialog box. I'm going to go ahead and make that table just a little bit wider. I want the customer number, the customer name, and the balance. Where the balance is greater than, or no, they say between 1,000 and 5,000. Your author actually has an error in the text at this point. Your author says, goes on in the example on pages 42 and uses greater than 1,000 and less than 5,000. Yet in the actual example they asked for between. Between is not greater than, it would be greater than or equal. Remember, between is inclusive. We'll just use the keyword between 1,000 and 5,000. Now in this situation, the criteria cannot all be seen in the column. There is no need to widen the column. However, many users do. They prefer to be able to see everything that they're working on. Eventually you'll work in queries that are so large that you won't be able to widen all the columns and without having to scroll left and right constantly. Notice that when I referred to the 1,000 and the 5,000, I did not put in dollar signs, nor did I put in commas. Both dollar signs and commas and things like that are formatting issues. You don't use all of that formatting when you have them in your criteria in the query. So when I go and take a look, I have 3 records that meet that criteria where the balance is between 1,000 and 5,000. I'm going to go ahead and save that one as query example 6 and close it. Example 7 is on page 43. Begins on page 43, and it says to list the number, name, and available credit for all customers. This is the point where they begin to introduce us to calculated fields, or they call them computed fields. And there's a number of different ways to get calculated fields. They're actually zooming in on it. I'll show you a couple of different ways to do this. Again, let's go ahead and create that query. All the data we need is in the customer table. And so first let's just look at what we would need to know in order to figure this out. We would need the customer name, number and name, and then we would need to know their credit limit and their balance. Remember, what we want to figure out is how much credit they have available. So for right now, I'm going to go ahead and include all 4 fields, and I'm going to go take a look at it. So when I look at Al's Appliance Sport, his credit limit is $7,500, but he currently has a balance of $6,550. So what I need the query to do is actually take this credit limit number and subtract this balance number. So I'm going to go ahead and go back into the design. It would be great if it could simply be as simple as going credit limit minus balance. And sure enough, it is that simple. You can see here how they've got the 7,500 minus 6,550 is 950. Many times the math you're doing is not that complicated. It's just that you want to apply it to dozens or hundreds or thousands of rows. So usually you can go in and check your logic simply by doing the math manually for the first one. I can do that math in my head. 950 is correct. But notice that my column heading says expression 1. That's not a very descriptive name. So when I get back here in the actual query, if you notice, I only typed credit limit minus balance. A couple of things happened that Access did for me automatically. For starters, Access put square brackets around my field names. It is not necessary for me to type the square brackets unless I've broken certain rules. They talk about this a little bit in the note on the bottom of page 43. A big one is spaces in field names. Many people, when they try to create Access databases or any databases, they try to name their fields things like credit, space, limit. Some programs don't allow this at all, but some programs like Access do allow it. But then every time that you reference that field in a form, a query, a report, in a macro, in your Visual Basic code, in your SQL, anywhere, simply because you included a space between credit and limit in your table design, you now must always type the square brackets yourself. The program will not know where to properly put the square brackets. By not including the space, Access was able to figure it out. So I've now eliminated the necessity of me typing those square brackets a huge chunk of the time. Furthermore, there are a few times that I would still have to do them. A good example would be if I had a field name that was some type of a keyword. Usually it won't allow me to actually name a field something like or and, but I have run into it where I've imported data in from another source. Thus the field was already named that, and I've had to then put the square brackets in myself. The other thing that happened automatically is it put this EXPR1 and a colon in front of my formula. And that's just giving me the ability to actually name it. A better name would be available balance. Notice that I got rid of the EXPR1, but I kept the colon. The colon separates what I want to name this column from the formula itself. Now when I take a look, again I can widen it here in the data view, this column is now titled Available Balance. Now the author did not add these two columns into the query, and I wouldn't have in real life either, but since it's the first time doing a calculated column, I wanted you to actually see the other two numbers that it's based off of. Coming back into the design, I'm going to go ahead and select right here at the top of the gray, click and hold both of these columns and just delete them out of there by pressing the delete key on my keyboard. So now I'm looking more like the example picture on page 43. Customer number, customer name, and then a formula, available balance, colon, credit limit minus balance. Notice that the fields I'm using in my calculation do not actually have to appear in the query. They do have to appear in the table above that I'm pulling the data from. Now what your author does is does zoom. To zoom in on something, it's simply Shift F2 in Access. Shift F2 opens up this zoom dialog box, and just instead of having to try to fit the formula into this small little space here, allows me to have this larger box for the formula. Now the formula this small, I would never have zoomed myself, but I often do on many larger formulas. As in my previous examples, I'm going to go ahead and save this and name it example 7 and close it. Our next example is on pages 44 and 45, and they want to know how many customers does sales rep 35 represent. Okay. All of that data is contained in the customers table. So I'm going to go ahead and create a query using the customers table. I need to see the customer name and the rep number. And we want only customer 35. Now, there's a couple of different ways to do this. Right now, I would see the actual names of the customers, and when I went, or excuse me, the numbers of my customer numbers, when I went into the data view, obviously I can count that there's 4, but if there were 4,048, I couldn't count them that quickly. But remember that my navigation buttons across the bottom will always tell me the total number of records or results in that data set. So it tells me right away that there's 4. But what we want to do at this point, though, is introduce you to some groups and totals. You have an icon up on your Query Tools Design ribbon. That's the third or fourth from the right, that has the Greek letter sigma and the word totals on it. And when you click that icon, it's going to add an additional row down here to your query grid, this total row. You'll notice that for both the customer number and the rep name, it has put in the words group by. But if I click on that, I'll see it's actually a drop down of choices. And one of the choices I have is to count. So now what I'm saying is I want to group by rep number, and I want to count the customer numbers. So now the query is actually counting and telling me that there's 4 rather than me having to look down here on the navigation buttons. When you first look at that, I think that's not that big of a deal, the difference, and that the first way I showed you might even be simpler. But let me show you. If I take the rep number out that the author has in there, and now I take a look at it, what it's doing is it's showing me all 3 sales representative numbers. So I can now see that the sales rep number 20 has 3 customers, sales rep 35 has 4 customers, and sales rep 65 has 3 customers. So I have 3 different sales reps, and it's grouping by the representative number and then counting, in this case, the customer number. I can have it count any field that I wanted it to. 35 is what the author wanted to see. That should make it look, the other thing that the author introduces here is maybe you don't really need to see the 35 when you're out here. You know what rep you asked for, so they're unchecking the group by box so that all you see is the resulting 4. As earlier, I'm going to go ahead and save that and name it example 8. For example 9, they want to know the average balance of all the customers of sales rep number 35. So again, all of that data comes out of the customer table. And I'm going to pull in the balance and the customer's rep number. And right now, if I looked at it, what I'm going to see are 10 records, because there are 10 records in the database. I'm seeing the rep number for everybody. I'm going to go back to the view and switch it to rep 35, and now I'm seeing just the four records that sales rep 35 has. So here's the balances of his four customers. But we want to know the average of those numbers. So again, I'm going to go to my totals icon on the Query Tools Design ribbon, and that adds this additional row that says group by group by. And this time when I click on the balance group by, rather than count, I'm going to choose average. You can see how this is now telling me that the average of customer 35 is $2,203.94. There's a variety of options there for me to group by. I could sum them. I could tell you min for the minimum or lowest, max for the highest. I could count them, standard deviation, variance, which one was first, which one was last. Expression's a little different. That's to put in a formula. Where is a little different. You need a little more complex queries to get into those. But there's quite a few functions right there that I can use. I'm going to go ahead and save this one, example 9, and close it. The 10th example begins on page 46, and they want to know the average balance for all customers of each sales rep. Well, let's go ahead and, as we did earlier, let's start with example 9. It's so similar to that query. So I'm going to right click on example 9 and choose design. Excuse me. And I'm going to go ahead and take out the rep number, the 35. So now when I look at it, I'm actually seeing all three of them. The average balance of customer 20, or representative 20, the average balance of representative 35, and the average balance of representative 65. But I decide that I would like these two columns to be switched around in my resulting query. So I'm going to go back into the design, and I'm going to simply click on the little gray bar at the top of either one of the columns. In this case, I clicked on the one on the right. Notice as soon as I click on it, then my mouse changes to a white arrow. I'm going to click and hold and drag it right in front of balance. So now I have the rep number first, the balance second. So when I look at the resulting query set, I see the same information, just the columns reversed. Because I started with example 9 and I don't want to lose that query, I need to make sure that I go into my Save Object As and change that to example 10. So now example 9 is still intact, and example 10, my new query, is there as well. The 11th example begins on page 47. They want us to list the customer number, name, balance, and rep for each customer. Then they want us to sort the output alphabetically by the customer name. Again, all the data that we need is in the customer table. The fields we want to see are the customer number, the customer name, the balance, and the rep. Here's my resulting data set. Now, the question is, what order does it sort in when you don't specify a sort order? It sorts in the order that it was input into the table. So in this case, and in most cases, we add the new customers get a higher number than the previous customer. So at first glance, you might think, oh, it's sorted by customer number. Reality is it's currently sorted on the order it was entered into the table. Most likely that would be customer number order, but I can't guarantee that. Maybe the day I was inputting, I was adding 2 new customers and I accidentally added customer 3 and then customer 2. Doesn't really matter, it's immaterial, but in this query, since I entered them in that order, that's the order they would appear, unless I specify a sort order. So I come back into the design grid, you'll notice this row right here says sort, and we want it sorted by customer name. When I click there, there's a drop down arrow and you'll see ascending, descending, not sorted. So one way for me to select a sort order is to simply choose from the drop down list. Here I've chosen ascending for customer name, and you can see that these records are now sorted in alphabetical order by customer name. That is example 11. For example 12, they want me to list the same information, sorting the output by sales rep number, and within the customers of each sales rep, sort it by output name. Sounds very similar to example 11. So I'm going to start with example 11. I've got my 4 fields, my customer number, name, balance, and rep number. This time we want it sorted by the rep. And then if the rep is the same, we want it sorted alphabetically by customer. Now you might at first think, oh, we'll just throw ascending down here for rep number. And so it says customer name in ascending order, rep number in ascending order, but that's not going to do it because the customer name is to the left of the rep number. Doesn't matter if it's 1 column to the left or 100 columns to the left, it is to the left. Therefore, the customer name is the priority sort order. So I'm going to come back into my design and I have to actually take that rep number column and move it to the left of the customer number. Again, I just clicked on the top of it and drug it over. And now when I look at it, now rep number is my primary sort order. Notice that I have my 3 customers for rep 20, and then they are sorted alphabetically by customer name. Here's my 4 customers for rep 35, and within the rep 35s, they're sorted alphabetically by customer name, and the same for rep 65. So within the query, the sort order, the columns have to be in that order left to right. Incidentally, sort orders become 1,000 times more important in your forms and your reports, especially your reports, than they are in a query or a table. And in both a form and a report, you can sort on any field, anywhere in the form or report, irregardless of which one is above or to the left of another one. And that's where you have your true power of sorting. This was example 11 that I modified into example 12, so I'm going to save it as example 12. And then I'm going to go ahead and see what they want for 13. For example 13, we're going to start to introduce the ability to get data from more than one table. We want to list each customer's number and name, and also the number, last name, and first name of each customer's sales rep. This example begins on page 51. So I'm going to create a new query, and I want to see data from both the customer table and the rep table. So I double-clicked each of those and closed. Notice that the relationship between the customer and the rep table automatically appeared as well. That's because the relationship was created back here in the relationships window before I even opened my data set. So since the relationship was created in the relationships window, the relationship will carry through now into this query. So one rep has many customers. The fields I want to see from the customer table include the customer number and the customer name. And the fields I want to see from the sales rep table include the rep number and the last name and the first name. So I have those 5 fields, and when I take a look back on my home ribbon to change views, you can see that I have all 10 customers. I have not put any criteria on this query. I've only joined or pulled data from 2 joined tables. I'm going to go ahead and save that query as example 13. The next query they want, which begins on page 52, for each customer whose credit limit is $10,000, we want to see the customer's number and name along with the number, last name, and first name of the corresponding sales rep. So again, this information is in some of it's in the customer table and some of it is in the rep table. And of course, I adjust those so that I can see all of the fields. From the customer table, I would like to see the customer's number and name. From the rep table, I would like to see the rep's number, their last name. I'm going to skip their first name and show you their credit limit. Oh, that came out of the customers table. So in this case, I've pulled a couple of fields from the customers table, a couple from the reps table, and then something from the customers table. I think it's just to demonstrate to you that you can go back and forth between whatever tables you want is as irrelevant as to what order they appear in the query grid. So now when I take a look at it, I'm seeing all of them, but they only wanted those whose credit limit was $10,000. So I'm going to come back into my design view, credit limit column, criteria row, and type in 10,000. Remember, never include dollar signs or commas when you type that in. So my ending result is these 3 customers. Now, I only pulled in the customer's last name, and the author wanted both their last name and their first name to appear. I wanted to show you how to string those together in a calculated field. I'm going to go ahead and just widen this column a little bit. And what I really want is the representative's last name, followed by a comma, and then followed by their first name. So I'm going to use the ampersand, the shift of the number 7 on my keyboard, to represent and in order it's a character that allows me to string items together. Now the next thing that I want is a comma, and I can't just type in a comma. I have to put that text inside of quotation marks, and I actually want a comma and a space. So I'm going to go quote, comma, space, quote. I have to do another and before I put the field name of first name in there. Now I haven't pressed the enter key yet because I'm thinking back to the previous time when I did a calculated field and the fact that it threw that EXPR1 and a colon in front of it. I'm going to beat it to the punch this time, and I'm going to go to the beginning of that, and I'm going to type, full name, or actually let's name it rep name and a colon. So let's see what happens when I press enter. Okay, notice that because I put the field name of the calculated field in first, it didn't waste my time with that EXPR1. So I put in the name and then the colon. Notice that it did put the square brackets around last name and first name for me. I did not have to type those. So my full formula is rep name colon square bracket last name square bracket ampersand quote comma space quote ampersand square bracket first name square bracket, and what's done is strung the name together, as you can see here. It's just another type of calculated field. This is a good example of when you really would not have a need to show a particular column. Because I've asked specifically for a credit limit of 10,000, that means whether I have 3 or 3,000 customers down that credit limit column is simply going to say 10,000, 10,000, 10,000, 10,000. So this is a good time when people often will uncheck this box to not show it. I have to have this particular field in my query, but I don't need to have that field, to see that field, because it's repeating itself in the resulting data set. So that's the time I might uncheck it. I'm going to go ahead and save that one as example 14. The next query is example 15. For each order, list the order number, order date, customer number, and customer name. In addition, for each order line within the order, list the part number, description, number of units ordered, and quoted price. This query by far has the most fields of any of them that we've done. We need data from the customer table, the orders table, the order line table, and the part table. It's 4 of our 5 tables. Let's review the relationships that already exist between these tables. One customer has many orders. One order has many lines. In other words, I might order 3 product X and 4 product Y on the same order. So I have multiple lines on my order. One part could appear on many lines. So I've got 3 one-to-many relationships between these 4 tables. The fields I want to see are the order number and order date out of the orders table, the customer number and customer name out of the customers table, By the way, it would not have mattered whether I pulled the customer name out of the customers table or out of the orders table. The part number and the description out of the parts table, and the number ordered and the quoted price out of the order line table. When I take a look, because those relationships exist, it's going to pull all of that data accordingly. So I can see my 9 orders, the date of the orders, the customer number and name of who ordered them, the part number and description of the item ordered, and then exactly how many of that item were ordered and what the quoted price was for that. I'm going to go ahead and close and save this and name it QRY Example 15. That concludes the first part of the Chapter 1 lecture. Have a great day.